Shablo yante, the Saba boy, Saba yoga. Le climat est pas mondi, on va pas où est le loin. Le bocon est si à bober, nous n'y voulons pas finir le kira pour avoir son compte à mon père. Je veux Shablo là, so. Bonne Joja, bonne comme la way, le bocon est Joja, sien, comme la way, elle ne sait pas la trouver sous la nous n'y voulons. Pas où n'y va son mon nom sous ta mon père, oh, sous la nous n'y voulons. Il faut que je sois qui est non Côte d'Ivoire, ouais, mon âge, la fille au son, ouais, ça m'a bien de moi, oh, maman. Comme la way, elle ne sait pas la trouver sous la nous n'y voulons. Mon Dieu, ça va pas nous coin, nous trouver. Y'a mon époque à Oloyon. Tu te portes à eau, on nous l'a eu doué, pourquoi ouais d'un mot? On est c'est pour la trouver sous la nous n'y voulons. Voilà, nous m'a commencé moi, comme les mains du soleil, les mains, ouais. Mon Dieu, t'es là, non, mon souvenir, mon Dieu, t'es ma non, là, mon waouh. Mon Dieu, t'es à la yomba, là, mon souvenir. De là, je loue à waouh. Y'a lui qui porte waouh. Voilà, nous m'a dit comme moi, lui qui porte waouh. T'as dit porte waouh. Voilà, nous m'a pas ouais d'un mot. On était pour la trouver sous la nous n'y voulons. Nous va son un soco, t'as mon père. Petit Kefin, Madé, sorry gueulon, bébé Kari, laissez à ce du soir le midi. La fino, assez Idawema, et Rodi, Yala, Stéphanie, c'est de l'école d'Ivoire, moi, ouais. Mon bon ouais d'un loin, on était pour la trouver sous la nous n'y voulons. La division est l'oyon sous ta mon père. Y'a mon époque à eau, Péri du sous pote à eau. Libre y'a bouille sogo, il va y dire. Pourquoi ouais d'un mot, moi comment y'a n'amour. Pourquoi ouais d'un mot, c'est un loup à comment y'a n'amour. Il y a l'oyon du web back à Nigeria. Y'a n'y a pas mon nom Nigeria. Ouais à comment y'a n'amour. Mon pourquoi ouais d'un mot, sous ouais à comment y'a n'amour.
Je rappelle que non José que Wanou le Yandei Youssou et Chablo Delphino de Kela le métan un podei mon doudou mon popo yabi de Rosette ne pourquoi ouais dan moi oh bien il est moi pourquoi ouais dan moi oh bien il est moi maman dei Rosalie maman dei lucky oh ne sais pas ouais non ne sais pas.
Again, folks, Samson Tob, I want to apologize for the interruption there. It's audio issue. I hope we have that resolved. But let's go on here now. I think we spent, maybe 15, 20 minutes of our time trying to resolve the audio issue. Hopefully, you guys can hear me. Because we do these things for you, not for ourselves. So whenever we have these issues, we try to resolve it. So please, let's continue with it. I've already shown you this. So this is the cross section of if it is something that they want to do. You have the lean going that way, you have the lean coming that way, and in the middle they have a crown. So please, folks, please help me share this video now because I don't have time to go through sharing. Hey, you don't have to, but if you can help me, I would appreciate it. But on the side of it, they have a ditch, and then on the side, on top of that, you can make that into a sidewalk, what have you. Okay, so let's show you another one. Then I can show you the fundamental of, okay, here's another cross section here, but this one they show you right away and the length and all that kind of thing, the weight of the roll and all that kind of good stuff. Okay, so based on this, if you have a true cross section which gives you cut and fill and what have you, you can do the calculation. Okay, let me show you now this short video which is fundamental of design, highway design. It's a very interesting one. It's a very interesting one. Let's pay attention to that, and then I'll come back on the other side. Samson to LIBERIA Public Radio.
This is a short video about roadway fundamentals. One of the things we do in our state in rural areas is we use a concrete cross section. We usually have two 12-foot lanes, two 6-foot full depth shoulders, and you can see they're usually connected with steel at the joint. We have this thing called a 3-foot paving machine pad, and I'll show you what that means in a minute. But that's to allow the paving machine to drive along the side and have a good base to drive on. We have sub-drains to drain all the water that's underneath the cross section, and it'll drain it out to the medians. And it's a pretty typical cross section, and once we come back and we do the cross section, it's paved, the machine goes off, we'll just cover this up with some granular material, and that's the cross section in the rural areas. You can see here's a concrete paver, here's the loose concrete on the left, and it just pours your cross section. And the cool thing too, it can break it. So what I mean by that is it can break it at 2% each direction and do your cross section all in one go. And that's where the machine pad is needed. So urban streets are similar, and this red line represents a cut line. So this might be you're building a new roadway and this is the existing ground. So you might have to cut this area out and fill this area in over here to build the rest of your cross section. Most cross sections have two 12-foot lanes. It could be up to 4 lanes, 6 lanes, depends where you are in the city. 2% is typically used to get the water to go off to the curb and gutter on the sides. We have a planting strip, put a little green area in, partially to make it look good and partially to protect the sidewalk where pedestrians are going. In the United States, we have a maximum grade of 2% cross slope. That's for the ADA, the Americans with Disability Act, so 2% is the max. And it's a typical urban street cross section. You can see here's one near where I work. Pretty simple. Two 12-foot lanes, a little curb and gutter, sidewalks, green area. On the bigger roadways, you're going to start seeing a few things. I just wanted to show you with this slide that typically we start with 2%, then we might go to 2.5% in the next lane, and then 3%. It's to get the water to drain off a little faster and a little faster. The more pavement you have, the more you have to drain the water off. And this would be a 12-foot lane with a 2.5-foot gutter over here. Typical cross section, two 12-foot lanes on both sides, a median, some green planting area. Things you got to think about, curb and gutter. You got to have curb and gutter. You're going to need some drains for the water, obviously. Sidewalk. You can see in some urban areas they don't have this green strip because they just don't have enough right-of-way. They don't own enough property to build this sort of thing. This is called a plan view. So when you're looking at a plan set, you're looking straight down from the sky onto your project. So this is a plan view. Typically in engineering drawings, we lay things out in a plan view. So this is a horizontal alignment. It's the alignment of the road. We're starting with station 0, going to 100, 200, 300. Some point along this curve, 132.56 feet. So that would be 132.56 feet from here. We use the horizontal alignment to lay out the stations, and from these stations we can see the elevations, and the elevations of the roads are called the profile view. So this is a vertical alignment, and you can see the station is going to correspond to different elevations so we can lay out the road. When you have a vertical alignment, things you have to worry about is the maximum grade you're allowed and the minimum grade. You don't want a big grade, 11%, because it's hard for trucks to get up carrying a full load. And you don't want a maximum grade going downhill of 15% because it's really hard on the brakes on big trucks. Other things you got to worry about is sight distance. When you're passing someone, you want to see oncoming cars, you got to worry about how your profile is working so that you can see other cars. 3 types: intersection sight distance, stopping sight distance, and passing sight distance. So intersection sight distance, there's a car here on a major road, a car here on a major road, minor road. There's the cars, and you're pulling in from a little minor road and want to get on the freeway. Well, the other cars can see you. The car on the left can see you at a certain distance. It's usually a triangular sort of system. That's what they're going to say they can see when they're driving along. and they can see the car. That's good. Car on the right, same sort of thing. You're going to be watching your lane and be able to see this car coming into traffic. So the last thing you want to do is put any trees in here so you block the view of these two cars on the major road. So you got to worry about intersection sight distances and obstacles that go in these different corners. When we design a road, we typically have straight sections, makes sense. We have curved sections, and sometimes we use spirals. Spirals are just a transition from a straight section to a curved section. In highway design, we don't use a lot of them, but if we have to, we'll use a spiral to reduce the force going around this corner. If it's a really high-speed corner, you might have a transition from a straight line to a curved line using a spiral. Typical roadway cross-section. If you're building new, your existing ground might look like this. So one of the things you want to do, you've got to be aware you're going to cut this material out, and you're going to need to fill this material in. So when they want to do a balance, a mass balance of cut and fill, they try to put the roadway somewhere that it matches this cut can fill this fill. That way you don't have to haul long distances or bring in extra material. So that's one of the things you want to look for when you build your profile.
Great, folks. That's exactly what I've been saying here for a very long time. When you're doing these things, you're going to have an alignment. And you saw there they have horizontal alignment, which I told you before is the road going like this. And then they have the vertical alignment, which is elevation going up and down. Right now, you saw the vertical alignment. I will show you here again, which pretty much like where Rowersfield Highway is right now. The grade from the top of the hill to the bottom of the hill, the slope is considered grade. The grade on most of the highway, they are not up to standard. If you go in your car fail in the middle of the road going uphill, you're coming back down. You're going to be rolling back down because the grade will not allow your car to just stand. All right, and especially if you don't have no brakes. So that's why you don't use the 8%. You don't use these 8% grading for first of all, 8%, you're not going to have a good side distance anyway. You use those kinds of stuff for 8% for the driveway, private driveway, and things like that. But not on a major highway. You want to see as clear as possible because you're moving with speed. And I will go into the design speed selection and things like those kinds as we go on, because I'm telling you, I'm going to do my best on this highway here. By the time the construction starts, those of you who have not done these kinds of work before, from a layman standpoint, you will have a clear understanding, not the complex design of it and things like that, but little stuff. So you will know when they start moving their equipment, you will know what they're doing. You will understand that. You might not be able to understand everything, but at least you will have the basic. Now, the reason why I'm not going to do the estimate tonight is this. First of all, let me show you this row again. Watch the alignment. The first one that I'm going to be showing you, the one that they call plan view, is the horizontal alignment, which is you going straight. But instead of going straight, they put curves in a row so you can be able to maneuver as you go straight. Because most of the intent of a designer, roadway design, is to influence the driver behavior. The drivers are your customer, but you also want to make sure to make sure they follow the rules. You're not just going to give them straight road from here all the way to Rhode Island, and you're asking for trouble because people they think that the freeways there they can speed, but if you put little curves in here and there, you can control it. And most of the curve comes about area where they find it economically not feasible to continue to the route, to use that alignment through that area. So they try to bypass the hillside. They try to bypass a huge tree. They don't want to fool around with it. The tree, I told you already, the environment group come out and say, no, this tree, you can't touch it. So you move your road and go around it. That's how you put these curves here and there. Now let me show you. This one is a very short one, but I want you to pay attention to the difference between horizontal curve and the vertical curve. Okay, So you will be able to understand where they are. Okay, so it's, let's watch this here. Let's watch this, and you should be able to see it. Next time, I will try to take the audio of this and put it up a little louder so you will understand what these people are talking about. But the first one you will see is the horizontal alignment. And the one below is the vertical alignment, which if you look at it, if you look at this vertical alignment, this is from YouTube. Anybody can access this. But you can see that if you look at it, just the line going up the hill and coming down, it's just a Ralphie Highway, just a Tower Hill. I'm serious. Just a Tower Hill. Look at it again. Samson told LeBron Public Radio.
We lay things out in a plan view. So this is a horizontal alignment. It's the alignment of the road. We're starting with station 0, going to 100, 200, 300. Some point along this curve, 132.56 feet. So that would be 132.56 feet from here. We use the horizontal alignment to lay out the stations, and from these stations we can see the elevations, and the elevations of the roads are called the profile view. So this is a vertical alignment, and you can see the station is going to correspond to different elevations so we can lay out the road. When you have a vertical alignment, things you have to worry about is the maximum grade you're allowed and the minimum grade. You don't want a big grade, 11%, because it's hard for trucks to get up carrying a full load. And you don't want a maximum grade going downhill of 15% because it's really hard on the brakes on big trucks. Other things you got to worry about is sight distance. When you're passing someone, you want to see oncoming cars, you got to worry about how your profile is working so that you can see other cars. 3 types: intersection sight distance, stopping sight distance, and passing sight distance. We lay things out in a plan view. So this is a horizontal alignment. It's the alignment of the road. We're starting with station 0, going to 100, 200, 300.
Okay, there's an alignment. And they put station. The reason why they do station, to be able to know if you're doing construction. Okay, at station 4, 5, 6, or station 6 plus 70. That means 670 feet from 0. Okay? Station 5 plus 50, 550 feet from 0 point. So then, okay, what's happening at station 550 feet? Well, that's the beginning of Samson Toll driveway. Where is this driveway? It's on the left-hand side. You do those in the layout, and you put all of those points on them. So that the contractor, when they come as a designer, you label all of these things so that when the contractor comes, he knows where this driveway is supposed to go. He knows what's the radius of that driveway is supposed to be. So all of these things are taken into consideration during your design. And that's why the station helps you to identify the area as long as you're moving along the station. The alignment is also a line that you base your design off of. It's okay. Most of the time, alignment is usually in the middle of the road. But sometimes some other people put in the curve, and that's you can do whatever you want to do. But the main thing is alignment is supposed to be in the middle of the road. So you use the alignment when you put it in the middle of the road. The alignment also control. You can come off of that alignment and have all of your elevations. And the elevation, the profile going up and down, the most important for drainage, so you will know where the water coming downhill or water coming on the other side, where it's going, where is the lower point. Another thing is how deep you want to go to have your structure section, how deep you want to cut, how much you want to fill. That's the profile. That's what the profile going to give you, because you have existing ground. In one place, no car, no road, nothing, but the ground does this also. The ground go up and down. So now you put an alignment on there, and you have existing condition that going up and down. But where it goes here, you say, no, I don't want to go follow that. I want to go under here. How much is this under here from your alignment to the top of the existing? That would be your cut. And if you go down the valley and they're going down like this here, where they come down, you say, no, I want to go straight up. How far it is from the bottom of the existing to the new proposed alignment, that will be your fill. Okay? And the other good thing about that is it also helps you to lay your pipes. Because if you're going to have an alignment or profile that slope this way, sloping downward, and then you come in, you say you want to drain up, it won't happen because you can put your pipe, but you won't be able to have good drainage. Because as you're going down, and instead of following the downward trend with your pipe, you start coming like this, you will start digging deeper and deeper and deeper. And it's going to be difficult to drain because most of the drainage system are based on gravity. You don't see people putting pump on there to assist the drainage system. They're based on gravity, and gravity like to do something going downhill. You throw something up, gravity bring it down. Except in total, I throw it up, you can stay there. Let me. You think I lie? Look at this. Look at me. You play with me right now, I throw you up, you stay there. Gravity is not bringing you down. Not in my town, Samson told folks. I just thought I'd put a little bit in there. But on a very serious note, that's what happens when you do these things. Another thing station does, stationing of our alignment. For example, I told you the other day, this whole highway, I think we have it down here. I think we have the number, some sort of a huge number I put down here the other day, if I can find it. Give me a second here. I get my note. Okay, all right. Here we go. Okay, I have another pen. I'm not going to worry about it. Okay, it's like 91,360 feet. That okay. If I do that and go by station, okay, so you go. That's a huge. If you're doing it by 100. Now another thing, stationing. You want to make sure most people go with 50-foot interval, but I like 25, and the reason is when I do 25, I don't care how long it is, but I have clear indication of what the ground is doing. Just give you an example. You have 50 here. So do you see what's going on in between 1 and 50? But if you have 25, you will be able to determine what's going on here, and another 25, you know what's going on there. And that's why most people use 25. But 50-foot interval is the standard, okay? But if you want to get clear, precise, well, not precise, but somehow close to an engineering estimate based on the quantity, I like to do 25, okay? But I will come down to that here. But that's the reason. Now, another thing the stationing will do for you, I just show you stationing. When you're doing an alignment, you put station on it. You say, I'm starting from 0. I'm ending on, in this case, that station going to start from 0 or maybe 100. You can start at any station. You can call it any number. But that should be your starting point to whatever you're ending, okay? The length is not going to change. If you start at 100 and you end it at 150, that's 50 feet. If you start at 0, you're still going to end at 50 feet. You can't go on unless you decide to push it forward, all right? So the point here is stationing, okay? When you have the station, they're very good to do calculations. I told you about area end method earlier, and the area end method goes by stationing, okay? Station from this point to this point, what's the square footage of the area that I have, and I will show you that soon. Okay, so let me show you now. As the reason why I said I wasn't going to do the estimate, because first of all, I don't have their design, and worst of all, I don't even have their how do you call it, cross section. At least if I have the cross section, I will be able to calculate the total cut and fill on this project, and I will be able to know. Now, if they're going to remove the road itself, I don't need typical section for that. All I need is somebody to core, to do a coring. Where you go and your machine go and core the asphalt and have something like this. Asphalt like this, what I'm holding in my hand. Okay? The thickness of this, I know how thick it is. So I know how wide it is. I know how long it is. So I can do the removal from the top to the base. The removal, I can tell you what it is. Okay? So the demolition part of the existing roadway, those are things to calculate, that they're not that difficult. But the main thing is, I know very well that if they said they want to build this road, what do you do with Tower Hill? You're not going to keep Tower Hill at the present elevation or
Typical roadway cross-section. If you're building new, your existing ground might look like this. So one of the things you want to do, you got to be aware you're going to cut this material out and you're going to need to fill this material in. So when they want to do a balance, a mass balance of cut and fill, they try to put the roadway somewhere that it matches this cut can fill this fill. That way you don't have to haul long distances or bring in extra material. So that's one of the things you want to look for when you build your profile. Typical roadway cross-section. If you're building new, your existing ground might look like this. So one of the things you want to do, you got to be aware you're going to cut this material out and you're going to need to fill this material in. So when they want to do a balance, a mass balance of cut and fill, they try to put the roadway somewhere that it matches this cut can fill this fill. That way you don't have to haul long distances or bring in extra material. So that's one of the things you want to look for when you build your profile. Typical roadway cross-section. If you're building new, your existing ground might look like this. So one of the things you want to do, you've got to be aware you're going to cut this material out and you're going to need to fill this material in. So when they want to do a balance, a mass balance of cut and fill, they try to put the roadway somewhere that it matches this cut can fill this fill.